Hello again, this is the chapter on periodic table, so we're going to be discussing how to use the periodic table. Remember that each exam will have a copy of this periodic table at the end of your exam, so don't try to memorize any information that is already present in this periodic table, but we will learn to use the periodic table. So you find that this is a table organizing elements. So this is a periodic table, is a table of elements. Everything in here are elements. Now they are arranged in vertical columns and in horizontal rows. Vertical means going from up to down, if you don't know. So anyway, vertical columns are called groups, and we have group 1, group 2, group 3, group 4, group 5, group 6, group 7. The last group is sometimes called group 0 or group 8. Now remember that these numbers are written in Roman figures. You should know that V represents 5, so a number before the V would be subtracted from 5, a number after the V will be added to 5. So this is 1, 2, 3, 4, 5, and then 6, 7, and 8 or 0. Okay, now the horizontal rows are called periods. So the first period includes hydrogen and helium, and then the second period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so on. The third period starts with sodium and so on. Okay, so you should realize that this is the arrangement of the periodic table. So this is a sample question. Diagram shows the positions of some elements. How many periods and groups are shown in this diagram? Okay, let's take a look. How many periods? There is one in which you have helium, and the other period is the one that has lithium, boron, nitrogen, fluorine, and the third period is the one that has magnesium, silicon, sulfur, argon, and that means I have 3 periods, right? Now, how many groups? 1 including lithium, 1 including magnesium, 1 including boron, and so on. So I have a total of 8 groups. Can you see that? Okay. Now, you should realize that the number of the group tells you the number of electrons in outer shell. This is going to be important in the next chapters. So if you have the periodic table, group 1, group 2, group 3, group 4, and so on, and I do the electron configuration of each one. So sodium, for example, has 11 electrons. If I distribute them, it ends with 1, and it is in group 1. Magnesium has 12 electrons. If they're distributed, they end with 2, so it is in group 2. Anything in group 3 will end with 3. So you would expect silicon to end with what? Without doing the electron configuration, silicon is in group 4, that means it has 4 electrons in outer shell. Phosphorus is in group 5, that means it has 5 electrons in outer shell. Sulfur is in group 6, 6 electrons in outer shell. Chlorine is in group 7. If I sit down and distribute the 17 electrons, yes, it ends up in 7. What about group 0? Argon, for example, is 18, so if you distribute it, it will end with 8. That's why sometimes we call this group 8. Okay, so the number of the group indicates the number of electrons in outer shell. What about the number of the period? The number of the period will tell you the number of energy levels that I have in this atom. For example, lithium, sodium, potassium. Lithium is in period 2, sodium period 3, potassium is in period 4. If I sit down and do the electron configuration, I find that lithium has 3 electrons, so 2, 1. That means it has 2 shells that contain electrons. Sodium has 11, 2, 8, 1. That means it has 3 shells. Potassium is 2, 8, 8, 1. That means it has 4 shells. So the number of the period is the number of energy levels containing electrons. Okay, so let's take a look at this sample question. Which element is correctly matched with its electronic structure? Now, without finding out what the number of electrons are and how we distribute them and things like that, I can determine what electronic structure is correct from just the position in the periodic table. For example, if I look at A is in group what? It's in group 1, so it should end with 1. So that is correct. The electronic structure there ends with 1. But then it is in which period? It's in period 2. So actually it should have only 2 energy levels, not 3. So 2 at 1 cannot be correct. Now if I look at B in the periodic table, in that periodic table there, now B is in which group? 1, 2, 3, 4, 5. So it is in group 5. So it should end up with 5, not 4. So that is wrong. C, where is C? C is in group 2. So it should end up with 2. That is correct. And it is in which period? 1, 2, 3. That means it should have 3 shells or 3 energy levels. So that is my correct one. D is something in group 8, so it would have 8 in the last shell, but then it is in which period? It's in period 3, so it cannot be 2, 8. Do we understand that? Just looking at it in the periodic table, you can determine what the number of electrons in outer shell should be and how many shells it should have. And you should know that all elements, when they're in the same group, they have same chemical properties because they have the same number of electrons in outer shell. Remember we said in the previous chapter that the chemical properties of the element are determined by the number of electrons in its outer shell. So looking at the periodic table like this, you should realize that everything on the left is a metal, so things in group 1, 2, up to 3 and everything in between are all metals. Things on the right are non-metals. There are some exceptions, but don't mind the exceptions. So the ones on the right are regarded as non-metals. So group 4, 5, 6, 7, and 8 are non-metals with some exceptions that we'll talk about later. Anything in group 1 is called an alkali metal. So if he tells you choose an alkali metal, you choose something in group 1. Everything in the middle there is called a transition metal. So that these are all transition metals. What about group 7? Can you see where group 7 is? Group 7 are called halogens. And group 8 are called noble gases. You should know these names. Okay? So let's take a look at this sample question. Which two numbers are metals in this periodic table? Metals in the same period. So which of these numbers are metals? First of all, we said metals, they have to be on the left. So it is 3 or 5 or 6 or whatever, not 1 and 2 and 4 and 7. Okay? Now, which two numbers are metals in the same period? In the same period, that means in the same horizontal row, so that is 5 and 6. Metallic and non-metallic elements are classified in the periodic table. Just ignore reactivity series for now, we'll talk about it later. So, metals and non-metals are classified in the periodic table. This can be used to do what to the properties of elements? Measure the properties of elements or predict the properties of elements. Remember that we use the periodic table or the position of the element in the periodic table to predict the properties of that element. Okay, which property of elements increases across a period? Okay, let's take this one by one. Metallic character, across a period, that means going from left to right. We said that the ones on the left are metals, the ones on the right are non-metals. So actually the metallic character decreases across a period, not increases. Okay, what about the number of electron shells? No, across a period, if we're in the same period, they have the same number of electron shells anyway. What about the number of outer shell electrons? Yes, number of outer shell electrons will increase from group 1, group 2, because anything in group 1 will have 1 electron, 2 electrons, 3 electrons, and so on. Tendency to form positive ions, let's just ignore that for now. We'll talk about actually the one that has more tendency to form positive ions are metals. So that decreases, not increases. Okay, what about this sample question? Which statement about the periodic table is correct? Let's take a look at each one of them. Elements in the same period have the same number of outer electrons. Is that correct? No, not in the same period, in the same group. The ones in the same group have the same number of outer electrons. Okay, the elements on the left are usually gases. Left? No, the left are metals. And metals are solids, except for one of them, which is mercury. So the elements on the left actually are usually solids, not gases. The most metallic elements are on the left. Yes, the most metallic elements are on the left, because the ones on the left, group 1, group 2, up to group 3, are all metals. The last one says the relative atomic mass of the elements increases from right to left. No, we're talking about the mass number. The mass number increases from the left to the right, not from the right to the left. Okay, which element is classified as a non-metal? If we look at the periodic table and we look for the positions of these, we find that chlorine is the one that is on the right, and that is the non-metal. Okay, let's talk about the groups in detail, each one. So we said anything in group 1 is called alkali metals. Now, alkali metals, if you look at the periodic table, are lithium, sodium, potassium, rubidium, cesium, francium. Let us, for our purpose for this syllabus, ignore francium completely, as if it's not there. So we're looking at group 1, and we're going to say group 1 is lithium, sodium, potassium, rubidium, cesium. Ignore francium. This is because actually francium is radioactive and it has different properties from the other groups. Anyway, just ignore it. Okay, so what are the characteristics of group 1? We know that if it is in group 1, that means it has 1 electron in outermost shell. Now, if we're talking about metals, these are very reactive metals. So anything in group 1 is more reactive than group 2. Group 2 is more reactive than group 3, and group 3 is more reactive than transition. So anything in group 1 is the most reactive metals. Now, we also refer to them as soft metals. So if he says choose a soft metal, it is actually anything in group 1. Okay. Now, which one is more reactive, lithium or cesium? You have to remember that if we're talking about group 1 or group 2, the ones down are more reactive than the one up. So cesium is the most reactive metal. So if I say, for example, which metal is more reactive than potassium, can you see where potassium is? Which one would be more reactive? More reactive is the one below it, so rubidium or cesium. Okay, you should also know that if we're talking about melting point is the opposite of reactivity. So if we say that in group 1, the ones down have the most reactivity, actually the one up will have the higher melting point. So the trend of melting point is opposite to that of reactivity. But if we're talking about density, density is the same as reactivity. So the one down is the one with higher reactivity, higher density, but lower melting point. So let's take a look at this sample question. The group 1 elements, lithium and potassium, are tested. Which element has the higher melting point and which element reacts more vigorously? So I look at the position in the periodic table. Lithium and potassium. Can you see where lithium and potassium is? Okay, if we're talking about melting point, we said which one is higher? The one up is higher. So lithium will have a higher melting point. Now, if we're talking about more vigorous reaction with water, that means I'm talking about reactivity. Which one is more reactive? We said the one down is more reactive. So actually, lithium is the one that has higher melting point, while potassium is more reactive. Do we understand that? Okay, which statement is correct for the element of proton number 19? Again, if you look at group 1, element 19 is potassium. So, potassium is a metal in group 1. Which one is correct? If he says it's a gas, that's definitely wrong. All metals are solids except for mercury. Okay, what about number B? It's a hard metal that is not very reactive. No, I wouldn't say that, because anything in group 1 is actually very reactive. Okay, C, it is a non-metal. No, group 1 is not a non-metal. Group 1 is a metal. D, it's a soft metal that's highly reactive. Yes, that's my answer. Okay, let's take a look at this other question. The table shows some properties of group 1 metals. What are the properties of rubidium? So if we're talking about melting point, we said melting point decreases as I go down. So if it is 181, 98, 63, then rubidium will be lower than 63. So if I say it melts below 63. Okay, hardness, we said hardness increases just like as he says, so lithium is moderately soft, sodium is soft, potassium is very soft, then you would expect rubidium to be very soft. Okay, reaction with water. Remember we said as we go down, the reaction becomes more vigorous. So I would choose the one that says reacts explosively with water. Okay? Okay, let's talk about transition metals. We said transition metals are the ones in the middle of the periodic table between group 2 and group 3. So, if we're asked about the physical properties of transition metals, and remember, is he asking you for physical or chemical? Physical properties, we are going to compare transition metals to the other metals, which are in group 1, 2, and 3. Then the ones that are transition will be harder, higher density, higher melting point. Okay? So transition metals are very hard, very high density, very high melting point. What about chemical properties? If you are talking about chemical properties that are unique to transition metals, then you should know that transition metals are the only ones that form colored compounds. Do you understand the meaning of that? That means the metal, as it is, metals are usually silvery in color, like aluminium, except for copper. Copper is not silvery in color. Copper is reddish brown. Gold is yellow. Otherwise, all the metals, whether transition or the other groups, are silvery in color. But when the transition metal forms a compound, so if I'm talking about cobalt, chloride, nickel, fluoride, manganese dioxide, whatever, if we form a compound from transition metals, then the compound is colored. Okay? But if we have compounds of group 1, 2, and 3, they're not colored. So if it is a solid, then we say it's a white solid. If it is a solution, we say it's a colorless solution. So if it is not transition, it has no color. Okay. Another thing is transition metals may act as catalysts. So if he says that, and if you remember what's a catalyst is a substance that is added to speed up a reaction. If he says that I added a certain substance X and it made my reaction faster, where do you think you can find it in the periodic table? We would say that it must be one of the transition metals. So transition metals may act as catalysts. They also may have more than one valency. Let us keep that in mind, and in a later chapter we will explain what we mean by valency. But these are the chemical properties of transition metals. So let's look at this sample question. Which of these elements is a transition metal? Okay, remember that a transition metal is a metal. So will it conduct electricity or not? All metals conduct electricity, so its electrical conductivity must be good, whether it's transition metal or group 1 or group 2 or group 3. Density. Remember that we said when we're talking about transition metals have very high density. So I look for something that has a high density. What about the melting point? High melting point, and that means that it is B, that must be a transition metal. Okay? He says an element melts at this, which is a very high melting point, has a density of this, which is a high density, and forms a green chloride. That means it forms colored compound. So where in the periodic table will I find it? It must be one of the transition metals. Right? Okay. Another sample question. Which properties of the element titanium can be predicted from its position in the periodic table? Now, if I look for titanium in the periodic table, I will find that it is a transition metal. So, transition metal, can it be used as a catalyst? Yes. Will it conduct electricity when solid? Yes, because all metals conduct electricity when solid. Will it have low density? No. We said transition metals have high density. Will it form colored compounds? Yes. So the one that shows the correct answer is A. Do we understand how to choose these answers? Okay. Another sample question. Positions of 4 elements are shown. Which element forms a colored oxide? Again, colored oxide means it forms colored compounds, and that means we're talking about a transition metal. Do we understand this? Okay, again, which element is a transition metal? Transition metal, the color of the chloride must be colored. So it's C or D. Melting point must be high. So my answer is D. Can you see how easy it is? Which element is used as a catalyst? Again, to be used as a catalyst, it has to be a transition metal. Okay, what about group 7? Let's talk about group 7, which are halogens. Halogens include fluorine, chlorine, bromine, iodine, and astatine. They're all in group 7, so they have 7 electrons in outermost shell. Okay, they are very reactive non-metals. So these are the most reactive non-metals. Okay, looking at group 7, which one is more reactive, the one on top or the one below? You have to remember that when we're talking about group 7, the one on top is the more reactive. Remember that we said when we were talking about group 1 and 2, which one was more reactive? The ones down are more reactive. But looking at group 7, the one up is more reactive. So actually fluorine is the most reactive non-metal. Do we understand that? You should realize group 7 are very reactive non-metals, and you should know the colors of and states of each one. So fluorine is a yellow gas, chlorine is a green gas, bromine is a reddish brown liquid. Sometimes we call it orange if it is dilute. So you can say either orange liquid or reddish brown liquid. Iodine has several colors depending on its state. So iodine as a solid, it's gray. So looking at the halogens, we say yellow, green, reddish brown, gray. The state, gas, gas, liquid, solid. But iodine, when I dissolve it in water and form a solution, it becomes a brown solution. Now, when I heat it, it sublimes. You remember what is the meaning of sublimation? Sublimation means when I heat it as a solid, it forms a gas directly. It doesn't go through the liquid state. And when it forms a gas, the gas is violet or purple in color. Okay? But when asked what is the color of iodine, it's a gray solid. Okay? The more reactive non-metal displaces the less reactive non-metal from its salt. And that means that if I am reacting chlorine with potassium bromide, the chlorine will displace the potassium bromide. Of course, we will have another chapter on writing the equations, but let's take a look at this. Chlorine plus potassium bromide, the chlorine is more reactive than the bromine, so it will push the bromine out and replace it. So this is called a displacement reaction, and the more reactive is the one that pushes the less reactive out. Now, what would be the color of potassium bromide solution? Potassium bromide is a compound of potassium. That means a compound of group 1. Compounds of group 1 are not colored, so that's a colorless solution. Chlorine is a green gas. Now, when they react, they form bromine, and that means the solution will become orange or reddish brown, because we said bromine is a reddish brown liquid. Okay? A more reactive metal will displace a less reactive metal from its salt. So chlorine plus potassium iodide will give iodine plus potassium chloride. The potassium iodide is a colorless solution. When it forms iodine, it becomes reddish brown solution. Why? Because chlorine is more reactive than iodine and can displace it. Do you get the idea? If I do it the other way around, if I try to react iodine with potassium bromide, you should realize that iodine is less reactive than bromine, so it will not react. The less reactive element will not displace a more reactive metal from its salt. So let's take a look at this. Element X is below iodine. Below iodine means it is astatine. So actually he's talking about astatine. Now, which row correctly shows the physical state of element X at room temperature and its reactivity compared to iodine? Now, if it is below iodine, do you expect it to be a gas or a solid? I said before that fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid, then astatine would be solid. Now, reactivity as we go down, is it increasing or decreasing? No, we said fluorine actually is the most reactive, and as I go down, the reactivity decreases. So astatine is less reactive than iodine. Do we understand that? Okay. What is the color of gaseous chlorine and solid sodium chloride? Now, what was the color of gaseous chlorine? We said chlorine was, sometimes it is written as green, actually green or yellow-green, but don't say yellow, because yellow is fluorine. So fluorine is yellow, chlorine is either you say green or yellow-green. What about sodium chloride? Sodium chloride is a compound of sodium. Sodium is in group 1, so you don't expect it to be colored, so it's going to be white. Okay? Fluorine is at the top of group 7. Which row shows the properties of fluorine? So it is at the top. So the color is brown or yellow. We said the color gets darker as I go down. So actually the fluorine is yellow. It is a gas or a liquid? It's a gas. Now, when it reacts with potassium iodide, will it displace the iodine or not? Yes, it should displace the iodine because it is more reactive than the iodine. So my answer is right. Okay. The table shows some information about elements in group 7. Which information about iodine completes the table? So if I say state, we said chlorine is gas, bromine is liquid, iodine is solid. So my answer is C or D. Color. Chlorine is yellowish green, bromine is brown, iodine should be a little bit darker. So the answer is gray. Okay. Group 0 or group 8 are called noble gases. They have full outer shell, and because they have full outer shells, they are unreactive. So actually this group contains unreactive gases. So if he says an unreactive gas, it is in group 0. These are the uses of some of them. Helium is used to fill balloons. Argon is used to fill light bulbs. Neon is used for fluorescent lights. Remember that all of them are unreactive. So if we say, why do we fill balloons with helium? Because helium is unreactive. Argon also because it is unreactive. When you fill the bulb with argon, the argon surrounds the filament. It is unreactive, so this allows the filament to burn or to heat up without burning. So the filament lasts for longer. So we use argon because argon is unreactive, and this allows the filament to last longer. Okay, let's try this typical question. He has a periodic table of his own, and he says a metal that reacts violently with water. Now we said violently with water means I want a reactive metal. Which of these is more reactive metal? We said anything in group 1. A noble gas is where? A noble gas is in group 0 or group 8. Group 2 metal, of course, the one in group 2 is E. Which one is the halogen? The halogen is the one in group 7. Right? Okay. An element does not conduct electricity. Exists as diatomic molecules. In which area of the periodic table is the element to be found? Okay. Element does not conduct electricity means it's not a metal. So it cannot be A or B. And that means it's either C or D. But I want you to remember for now that D are monatomic molecules. That means each atom forms a molecule. The group 0 or group 8, each atom forms a molecule, or the molecule is made of only one atom. While the ones in group 7, each molecule is made up of 2 atoms. So we call it a diatomic molecule. So that is C. The diagram shows a section of the periodic table. Which element is described below? He says a colorless, unreactive gas that is denser than air. First of all, when he says a colorless, unreactive gas, so that means I'm talking about something in group 8. So it is A or D. But then he says something that is denser than air. So which one would be denser? A or D? You should remember that as I go down in the nonmetals, the density increases. So D is actually denser than A. Okay? Helium is a noble gas. Which statement is correct? Let's take a look at them. A helium atom has 8 electrons in its outer shell? No. If you look at the periodic table, helium has an atomic number of 2. So actually it only has 2 electrons. That's it. Helium exists as diatomic? No. Remember that group 0 or group 8 are monatomic, or the molecule is made up of only one atom. Now, helium is used as inert atmosphere in lamps, Well, not really. We said which ones do we use in lamps? We use argon, not helium. There are no naturally occurring chemical compounds of helium. Yes, because helium will not form a compound because it is unreactive. Okay? Let's try this one. The diagram shows electron configurations of 6 different atoms. Now, I want something that's a noble gas. Remember, a noble gas means it is in group 0. Okay, so group 0 means it has a full outer shell. So I need to look for which one has a full outer shell. So that is E. Okay, which one contains 3 protons? 3 protons means a total of 3 electrons. So you're looking for something that has a total of 3 electrons. So it must be B. Phosphorus, I look for phosphorus and I find that phosphorus has an atomic number of 15 in the periodic table. So it must have 15 also electrons. So I look for which one has 15 electrons. Okay? An element in group 4. When he says group 4, what does that tell me? It tells me that it has 4 electrons in its outer shell. So we're looking for something that has 4 electrons in the outer shell. An element in period 3, remember period 3 means it should have 3 energy levels, 3 shells with electrons. With a full outer shell of electrons, again, which one has a full outer shell of electrons? Okay, remember that the outer shells are filled with 8. The first shell takes 2, the next shells take up to 8. Okay, let's try this one. Answer the following questions. Okay. Which one is an element in group 3? Again, group 3 means has 3 electrons in its outermost shell. So which one has 3 electrons in its outermost shell? So that's C. Which one is a monatomic gas? Again, we said a monatomic gas means it's something in group 8 or group 0, and that means it has a full outer shell. Which one has a full outer shell? Okay. Carbon, if I look at the periodic table, carbon has atomic number 6. It is in group 4. So which one is carbon? Okay. What has 18 protons? A total of 18 protons means a total of 18 electrons. 18 electrons means 288. So that is B. Will you be able to do these questions? Okay, so this is the end of the chapter. Please study it, try the chapterized questions, and we'll come back with the answers.